and gentlemen. So today we're going to be reviewing, I shouldn't say reviewing, this will be new, sorry. Today we're going to be talking about another type of equation called absolute value equations. And these are new. We did a little bit with absolute value last year. We're going to do obviously a lot more with it this year. So the idea of, and remembering that the absolute value is the distance a number is from zero. And that means that there are always going to be two numbers that have the same absolute value. So for example, in number 1, I want to know what value of x would give me an answer of 5 if I take the absolute value. Well, of course, the first one is always going to be 5. But the other one is that on the other side of 0, there is -5, which is 5 spaces away. So those would have the exact same value. Number 2, or the same absolute value. Number 2, absolute values always have to be positive. So for number 2, there is no number that is -4 spaces away from 0. So this one has no solution. And one thing that we didn't talk about earlier when we did no solutions is that you can actually show that using the fancy brackets that I can't draw with nothing in them. That means no solution. All right, so how are we going to solve these? Well, similar to what we were doing before, we have to now isolate the absolute value bars, which means if there's anything that's outside of them, being added, subtracted, multiplied, divided, you have to get rid of those first. So when I look, I'm going to kind of do this example as we go through. When I look at number 3, I don't have anything else with the absolute value, right? I have absolute value of 2a minus 5. So I don't have to worry about that. Then I'm going to split it into two equations. One where the number is positive, one where the number is negative. So they're going to look like this. I'm going to have 2a minus 5 equals 7. And when I write those, I get rid of the absolute value signs. And then I have 2a minus 5 equals -7. Because like up here, there were two values that gave me the same absolute value. Two numbers. Now we're going to go through and solve these like we normally do. So I'm going to add 5 to both. So 2a equals 12. Divide by 2, a equals 6. Over here, we're going to add 5 to both sides. But this time, 2a, -7 plus 5 is -2. Divide both sides by 2. Let me just remove this a little bit. And you're left with a equals -1. When you do this, you need to write your answers as a solution set. Anytime you see that word set, it means that you have to put it in fancy brackets. So you're going to have fancy brackets, and I can't draw them. And you usually list them in order from smallest to biggest. So -1 and 6. This part, the check on your calculator, I'm going to show you how to do that in class because it's too hard without trying to pull up something to show you how to do that. So it's, you isolate the absolute value bars, solve your equations, and then we'll talk about the check in a minute. So let's try going a little bit harder. So here, and this is where maybe drawing your line for the equal sign, actually I made that a little too big, might help you a little bit to just kind of see, okay, where is the equal sign, is there anything else? So over here, I have to cancel 4 before I can set up those equations. So I'm going to subtract 4 from both sides, because it is adding, and we have absolute value of 2x minus 1 equals 4. From here, I can set up my two equations. I'm going to put them over here just so that I have enough room. So I'm going to have 2x minus 1 equals 4, 2x minus 1 equals -4. So add 1 to both sides, 2x equals 5. Divide by 2, so x is, and remember we're going to keep these as improper fractions. Add 1, 2x is -3, divide by 2, x is -3/2. And then we're going to write it as a solution set. And I like to put the smallest first, and then the biggest. So -3/2 and 5/2, and we'll worry about a check later. For number 5, sorry, I have a 4 on the outside. It's being multiplied by the absolute value. So first I have to cancel that by dividing. So we're going to have x minus 3 equals 5. Now I can set up my two equations. So x minus 3 equals 5. X minus 3 equals -5. Add 3 to both sides, so we're getting x equals 8. And then add 3, and you're getting x equals -2. Solution set, -2, 8. All right, for number 6. Now when I look at this, what I have here is I want an absolute value to equal -1. That can't happen. This has no solution. If I write it as a set notation, or as a solution set, I'm sorry, then we're going to have an empty set, nothing in it. All right, number 7. So now I have to get the absolute value bars by themselves. So first I'm going to subtract 8, so that part's the same, right? You have to cancel adding or subtracting before multiplying and dividing. So we're going to have 3 absolute value of -8x equals 72. We're going to divide by 3. So we're getting -8x, absolute value equals, hold on, I have that done. 24. Now I can set up my 2 equations, and again, I'm going to do that over here just because I ran out of room. So we're going to have -8x equals 24, -8x equals -24. Divide by -8, so x is 3. Divide by -8, x is -3. Put it in your solution set, and you're done. All right, so definitely something new, but if you can remember that when you have absolute value, you have to set up your 2 equations, you should be okay, because then the steps from there are the same that we've been working on. But any questions? Bring them to class. Have a good night.